Hello there, this is Arun and welcome back. So, we have seen that one of the unique selling points of Java is its platform independence capability without compromising on execution speed, and we know that it because of Java. Platform independence was possible in JVM installed on a particular platform can interpret Java bytecode without any issues. And since Java bytecode is designed specifically to be interpreted by JVM, we also get very fast execution of speed. And we also said that JVM can be additionally perform something called JVM compensation, which makes executing Java programs even more faster so they can execute super fast. So JVM is the cornerstone of Java and it has other important benefits too, and it is a very sophisticated software, and it is so good that even programs written in the other popular languages like Scala and Groovy can be compiled into Java bytecode, which can then be run on any given. That way, they also get the benefits of Java, such as platform independence and fast execution speed. So, to run on JVM, all you need to do is produce Java bytecode. So, you need compilers which can produce Java bytecode. Since JVM plays such a virtual role in making Java really attractive and making it one of the most popular languages out there. It is important to have a good understanding of JVM. We have a separate chapter dedicated to JVM, but this point let's at least get a good high level understanding of JVM and also its architecture, and we will also see why Java program run as fast as C or C++ programs. So it is very important to understand this instead of just diving into the code. So we need to know why Java program run very fast. Java virtual machine is called virtual, and that is because it is an abstract computing machine that is like a real computing machine. It has an instruction set which it executes, and it is instruction sets is the Java bytecode. So for a CPU machine code serves as instruction set, while for a JVM Java bytecode serves as the instruction set. Unlike a real computing machine, JVM also manipulates memory at runtime. That is, it uses memory to run it is programmed and to manipulate their data. Not that term runtime here refers the time when the program is actually executed. And I said earlier, JVM is the cornerstone of Java platform, and it has the few core responsibilities. And one is loading and interpreting Java bytecode. We know that interpreting Java bytecode helps achieve platform independence along with the Java fast execution speed. So it is very fundamental responsibility of Java. And next is security. Security is critical as a Java was developed for a networked environment where programs can be downloaded from across the network. And you don't want these programs to perform any harmful activities on the user's machine. And third is automatic memory management. Unlike C or C++, Java relieves its programmers from directly manipulating memory, and it does that through it is automatic memory management process. And this is makes programming in Java easier and also makes the Java programs a lot of safer. That is, it will greatly minimize some really nasty memory related errors that one might it make if they are manipulating the memory difficulty. And as we will soon see, JVM has separate components to manage these responsibilities. And before we look at what constitutes JVM, let's first look at what happens when a Java program is run. Let's say we have a Java program called hello, and now when we execute this program using the command java space hello, and an instance of JVM is created and is loaded into memory. JVM then loads the hello program into memory and executes it. As you can see here, both JVM and the hello program are now in memory. So each Java application like the hello program here runs inside a JVM instance, so we can see the JVM instance here. Not that a JVM instance runs only one Java application. Now, if you want to run another program at the same time, then you can execute it separately. So, for instance, while the program is running, if you want to run another program, let's call it as goodbye. Then you would say Java space goodbye, and with that would create it another instance of JVM, which will then execute the goodbye class. So two Java JVM instances are being run at the same time, just like the way you can have two instances of the your browser running at the same time. And now let's look at typical architectural of JVM. Let's assume we have the Java program called hello or Java which is compiled. Next, we need to run it, and so we would say Java space hello, and we know with that JVM will be launched. That is, it will be loaded into memory as we just saw in the previous slide. And the same time, Java will also get a chunk of memory from underlying operating system, and we are referring it as runtime data areas. So it is a just the Java memory. JVM now has to load class, which includes the Java bytecode. For this JVM invoke the component called class loader, which as the name implies it locates allow class and loads the corresponding bytecode into memory. So as the name of the class suggests, it loads the class, and when we say memory, it would be these two areas called heap and method area. Next, the bytecode are verified by a component called bytecode verifier, and this is to ensure that loaded class file is not corrupted. And this is very critical because certain Java application we know that classes can be downloaded from across the internet, like in the case of applets, and these classes could have been created by some hackers. So bytecode verification is critical, ensure that Java integrity of the Java. So once the bytecode has been verified, and if there are no issues, then it can be safety executed by the execution engine, which includes the Java interpreter along with the JIT compiler. So the interpreter here interprets the Java bytecode. So this execution engine, which includes the interpreter and the compiler, give us benefit of the platform, independence and very fast execution speed. So it handles one of the core responsibility of JVM, which we discussed earlier. So collector is the component that is responsibility for automatic memory management, which as we mentioned earlier is another core responsibility of JVM. And as the name implies, garbage collector collects the garbage our program, which would be things that are no longer useful, and admin should reclaim the memory access by those things. Next, security manager is responsible ensuring the for security, which is another core responsibility of. For example, if you want to restrict any bytecode from accessing your file system. The security manager can ensure this is by running the bytecode in a more restricted environment called in the sandbox environment. Finally, there are also few other component of constituted of JVM, but let's not worry about them. I think we discussed some of the main ones here, and it should have given you a fair idea about what constitution of JVM. In JVM internals chapter, we will discuss many of these components in detail. Now let's spend little bit of the time discussing JIT compiler as plays critical role is making Java program run very fast. Just like in this case, C or C++, we already discussed this. Interpreting Java bytecode is much faster than interpreting source code. This because bytecode is designed specifically for Java and is already compiled and also sometimes optimized. So let's see how JIT just in time compilation helps further speeding up the execution. So as the program is executing and bytecode is being integrated, interpreted, JVM monitors frequency of execution of each piece of executed bytecode. Some of the code is more frequently executed than others, and frequently executed code is referred to as hotspot. Hotspot are the given G18 compiler, which is the component of JVM, as we just saw. And J80 compiler converts the hotspot to machine code, and this machine code is then cached, which means that it saves memory for future use. And in future, whenever there is need to execute these hotspots. This corresponding cached machine code is what gets executed, resulting in much faster performance. Rest of the code still interpreted by the interpreter, so the frequently executed code, that is, the hotspot is not interpreted every single time. It is corresponding cache machine code is what gets executed directly, and this is compilation is referred as dynamic compilation, as the compilation into machine code also is done dynamically at runtime. Now let's try to understand this genetic compilation process through a simple example. Let's consider that we have these two methods called FOO and BORM and some programming language. Methods are just referred as function. So in the Java we call them as methods, and we will discuss methods in next chapter. Essentially they are blocks of code represent certain logic to be executed here, and JVM represents some logic, bar would represent something else. Now, let's consider this method bar as here as 15 lines of code. Now at the runtime, the bytecode corresponding each of these 15 lines of the code in is interpreted and the corresponding code is executed. Now, this is happens the first time method executed, and also happened the second time, so until say 1000 times, and every single time the bytecode corresponding of every line of code here is interpreted and corresponding machine code is executed. Now then run for 1000 times when this in the for method could be considered as frequently executed code. So JVM we are designated as hotspot, and with that game with the JIT compiler would then kick in the would generate his own machine code version of this entire method. On JIT compiler, like regular compiler could have done some optimization when it generating this machine code, and this JIT generated machine code then catched. And the when bar method executed in 1001 time, cache machine code will be executed directly. So there is no more interpretation of the bytecode corresponding to the 15 lines of the code than bar method has. Since machine code is being executed directly, It would run very fast, just like code written C or C++, where CPU executes compiled machine code directly. So you can see that there is no difference here. So that why Java is considered as almost as fast languages like C or C++. Now here bar is executed for say 2000 times, then it might trigger another round of optimization by the JIT compiler for further speed of the execution. Not that method. Put may FOFO may not be frequently executed and hence might be interpreted every single time. So this is how conceptually a compiler would work. The actual way which works could differ slightly, but conceptually this is how would it is work would work. They so that is about it, and that is a high level overview of JVM. And you can see that is very highly sophisticated piece of software that makes Java programs run very fast and securely and also platform independently. That's it. Thank you.